In this question, we are required to calculate the number of grams that we actually need to make up a solution. This is a very common problem that people encounter in the laboratory. That is what people do every day. So how are we going to address this question? Well, we can do that in two steps. The first step is that we calculate the number of moles that we need in our solution. So we've got a volume and we have a required concentration. So step number one is find the number of moles. Find moles that is required. And once we know the number of moles that we need, we will convert them in the second step to grams. So convert moles to grams. So that will be our approach. So with the first step, we want to find out the moles that we need in this solution, and we can write our typical equation. The concentration equals the number of moles divided by the volume that we have, and we can easily rearrange this equation and make n, the number of moles, the subject. So n equals C times the volume. And we can put in our numbers. We need to be mindful that we've got molar and milliliter here, so we need to take that into consideration. So the number of moles in our solution would be 179 times 10 to the power of -3 mole per liter. That's our concentration here with the millimolar. And the volume would be 515 milliliters, so that would be 515 times 10 to the -3 liter. And we see that the unit liter cancels out and we've got mole left, and that is exactly what we want. And now we could calculate that, but I suggest we wait a little bit because then we avoid any rounding errors. So what we then do now in the second step, we convert this number of moles into grams. And we can do that. We can, for example, calculate this with the equation of the number of, we can say the unit for the molecular mass. That is given as the number of grams divided by the number of moles by n. And now we just simply have to make the unit that we are interested in, the grams, the subject, and we bring that to the other side. So we've got gram equals the molecular mass, and I write it like that, times the number of moles. And that is the number of moles that we just calculated. So all we need to do is we need to put in the numbers, and we get for our amount in grams that we have to use, we need the molecular mass, that is 880.5 gram per mole, times our number of moles that we just done here. And now we just simply can take this, what we've written here, and put that in. So that is 179 times 10 to the -3 mole. The unit liter has been cancelled out already, times 515 times 10 to the -3, and the liter have disappeared. What we see is that the unit mole also cancels out, and all we have got left is grams. And when we put this into a calculator, we would get 81.2 grams, which of course we can also write in scientific notation as 8.12 times 10 to the power of 1 grams. And that's of course with a little bit of rounding, but this is actually how you would address this problem. I hope this makes sense, and thank you very much for watching.